This video is going to cover the basics about the solubility rules. And then your goal for this lesson is just to be able to classify different compounds as either soluble, meaning that they will dissolve, or insoluble, meaning that they do not dissolve. So just to kind of review a little bit of this information, we know that ionic compounds, right, these are going to dissociate into ions. So here we can see some different images here. Like for example, this beaker here contains an ionic compound, sodium chloride. And it has the different ions. We can see the positive sodiums and the negative chlorines. So remember, an ionic compound is just when we have a metal plus a nonmetal. And those are going to break apart into those different ions. For our covalent, so here we have a covalent compound, like sugar, it does not break apart into the ions. It's going to stay as a molecule. Now, remember, one little bitty molecule is very tiny. We cannot see it. So that's why when sugar dissolves, we don't see it because it's still tiny, but it does not dissociate. So dissolve and dissociate are not the same term. They don't mean the same thing. Remember, dissociate means to break apart into ions, whereas dissolve just means that it's going to break apart into the tiny little molecules itself, and we wouldn't be able to see it anymore. Okay, so just make sure you don't get those two terms confused. For solubility rules, we need to be comfortable naming our compounds because our rules are all based off the type of substance we have, and so we need to know how to name it. So remember, whenever we name anything, we have to change the ending to "ide." We will see those Roman numerals for our elements that have multiple charges. And then we also use those polyatomics a lot. So these are on our purple sheet. If you want to grab that, we're going to be using the purple sheet a lot for the rest of this lesson. So let's look at a few of these compounds. So I'm just going to kind of number them here. So for number 1, and then feel free to write these down on your notes somewhere, or get out a piece of paper to write this down if this is something that you need to review. Okay. So let's name the first thing, right? So we have Ca, which is just calcium, and then we have S. So S is just sulfur, but remember, instead of writing sulfur, we're going to write sulfide because we changed the ending to "ide." Then we just need to look and see, do we need to use the Roman numeral? Do we have multiple charges? So we're going to look on the back of our periodic table, and we'll see that there's only one charge for calcium, so that means we do not need Roman numerals. Okay, let's look at number 2. So again, we're going to name the first thing. So we have iron, and then we have chlorine, but remember, we're going to change it to chloride. And then again, so I did the first thing. Now we need to look at Roman numerals. Do we need Roman numerals? Does it have multiple charges? And if you look on the back of your periodic table, you will see, yes, it does have multiple charges. So that means we need Roman numerals. So how do we know what charge iron is? If you remember, when we write our rules, so let's look at something like sodium sulfide. Remember, we crisscross our charges, okay, when we write our formulas. So that means that if I want to know iron's charge, I can just uncrisscross, and that will tell me its charge. So iron 2 chloride. Okay, let's look at one more. Let's look at, I'm gonna skip number 3. I'll let you try that one in a second, but let's look at number 4. Okay, so for number 4, we have Cu, which is copper, and then we have SO4. So remember, whenever we have something that is multiple things, right? This is not on the periodic table. It's sulfur and oxygen combined. This is a polyatomic. So remember, anytime we see these two elements that are bonded together, that's our polyatomic. Okay, so I'm going to look at the purple sheet. I'm going to find SO4. And I know that it is a sulfate. Okay, so copper sulfate. But copper, right, it has multiple charges. So I need to see what Roman numeral I have. This one takes a little bit of thinking because off the top of my head, it might look like there's no little number down there. But if we think about it, if we look at our purple sheet, sulfate, SO4, has a 2- charge. So remember, the whole point of writing our compounds is we want those charges to cancel out. So if we look back over to our sodium sulfide over here, the reason we had 2 NAs is because each of them have a +1, and then we only had 1 sulfur because it has a 2-. So those charges all cancel out. I have a +2 and a -2. So if I don't have any extra little numbers down here in my formula for copper sulfate, that must mean that my charges cancel out. So if sulfate has a 2-, that means copper has to have a 2+ so that it cancels out. Okay, so let's do one other one together. We'll go ahead and do this number 3 together, and then I'll let you try 5 and 6 on your own. So again, we name the first thing calcium, and then we name the second thing. So again, I have this double compound, right? There's 2 elements. That's a polyatomic. Look on my purple sheet. It is nitrate. I check, do I need Roman numerals? Calcium only has 1 option, so no, I do not need Roman numerals. So I want you to take a second and try 5 and 6 on your own, and then you can check your answers. So here we're going to name the first thing, aluminum. Name the second thing. This is fluorine, but remember we change it to ide. And aluminum only has 1 charge, so no Roman numerals. For number 6, Ag is silver. It's important that you know that Ag is silver. And then we have another polyatomic, PO4. That is phosphate. Silver only has 1 charge, so there's no Roman numerals there. So why is it important that we know how to name our compounds? On your purple sheet, again, right? Everything's always on our purple sheet. This is going to tell us our rules for if something is soluble or if something is insoluble. Okay, so even at the top, you have the term soluble, you have insoluble, okay, and then how we designate that. So if we look at number 1, it tells us, sodium, potassium, ammonium compounds are always soluble. Okay, so this is why it's important that you know those symbols. You know what sodium is, you know what potassium is. Ammonium sounds kind of weird. It doesn't sound like something we took an element quiz on. So that tells me it's probably on my polyatomic sheet. And there it is right here. Let me highlight it so you can see it. There it is right there. Okay, ammonium. Number 2 is talking about nitrates, acetates, chlorates. Again, that does not sound like something we took an element quiz on. So that's probably a polyatomic. And look at that. Here's our nitrate, acetate, chlorate. So anytime you have something that ends in ate, those are going to be your polyatomics, okay? For some of these rules, though, we have this term except. So, like chlorides are soluble. That means anything that ends in a chlorine is going to be soluble, except silver chloride, mercury chloride, lead chloride. Okay, so we have some of these that are exceptions. So we can use these rules to try to help us or tell us whether something is soluble, whether it's going to dissolve, or whether it is insoluble, which means it will not dissolve. Okay, so let's look at a few practice examples. So Na, right, that's sodium chloride. So I'm going to find my rule on chlorides. Rule number 3, it says they're soluble except silver, mercury, lead. Nothing about that is sodium. Okay, so that tells me that this is going to be soluble. If we have something that is soluble, a lot of times we use this symbol AQ. That tells us aqueous. All that means is, I'll write it over here. AQ just means soluble in water. That means it's dissolved. So if we have an aqueous solution, that means we have something dissolved in water. Okay, let's look at, this is CaCO3. So calcium and then CO3, that tells me probably a polyatomic. Here's CO3 and it's a carbonate. So I want to find a rule about carbonates. So let's see, rule number 5. Here's a rule about carbonates. So let's see what it says. It says they are insoluble, but I do have an except sodium, potassium, and ammonium. This is calcium though, so that doesn't fall under any of my exceptions. So that means it is insoluble. Okay, let's look at another one. This is Mg, magnesium, sulfur, sulfide. So let's find a rule about sulfides. Here we are right here, sulfides. Again, it says they're insoluble, and then we have some exceptions. Is magnesium listed as one of those exceptions? No, it is not. So that means it is insoluble. Sometimes our insolubles, right, we can write as an S. So what does that mean, right? If something doesn't dissolve, that means it just looks like a solid still, right? It still just kind of sinks to the bottom and stays a solid. So that's what the S means. It means it's insoluble. It is still a solid. All right, let's try one. Let's just keep going, I guess. We'll do a couple more. Here we have aluminum, and then NO3 is a polyatomic. Let's see if we can find that. Here it is, NO3, nitrate. So let's find my rule about nitrates. Here we are, rule number 2. It says they are soluble. So that means it's an AQ. Okay, let's do one more. Let's try this one over here. PB, remember it's not peanut butter, it's lead. And then SO4, so that's another polyatomic, right? Because it's more than one thing. It's a sulfate. So let's see if we can find a rule about sulfates. Here we are with number 4. It says most of them are soluble, but there's some exceptions. So remember, we said PB is lead, and it looks like lead is an exception. So that means if most of the time they're soluble except lead, that means this has to be insoluble. And again, remember, we can use that S term there. Okay, so what I want you to do is try these 4 here on your own. Okay, and then use your purple sheet. See if you can figure them out. And then I'll have you tell me your answers on the next question. All right, let's go over them really quick. So this is potassium phosphate, right? Polyatomic right here. For this one, potassium, we can use different rules here. They'll never contradict each other, but some of them fall under 2 different rules. So here, I'm just going to erase some of this so it's not so confusing. So here we have a rule about potassium, and it says they're soluble. Okay, great. We already answered, soluble. If you wanted to use the rule on phosphates, we could find that. Phosphates, it says they're mostly insoluble except potassium. So potassium falls under that exception, making it soluble. Okay, so again, your rules will never contradict each other. Just find one that works and then use it. Here we have another potassium sulfide. So again, we said potassium is always soluble, so we'll use that. Here we have a silver chloride. So let's find our chlorides. It says they are soluble except silver. So silver is one of our exceptions. So that means it is insoluble. Okay, and then we have calcium sulfide. So let's see if we can find something. Here's our sulfides. They are insoluble except calcium. So that must mean this is soluble. Okay, so what you're going to do now is complete the coloring sheet. Okay, and you're just going to be using these same rules. So if it helps you to like keep this video paused on this so you can see a few examples, that's fine. Grab you some colored pencils. You're just going to use your solubility rules and your polyatomic ions to help you fill in the sheet with the correct colors.